Yes, hello, my dear students. Welcome back to the St. Joseph Composite PU College, Vijaypur. I'm Rahul. And today I just want to introduce one topic, the topic first, that is known as some basic concepts of chemistry. Okay, before I start with some basic concepts in the chemistry, I want to explain you that what is the meaning of chemistry. If assume that if I provide you some kind of matter, okay, and you first study the what kind of atoms are arranged in that. Assume that these are the atoms, right? Let me take exact atoms here. These are the atoms, and these atoms are randomly arranged. You can notice that the atoms are very randomly arranged here. Okay, let me write here is one and here is one. The atoms are very randomly arranged, and that is you studied, and in that some kind of atoms are there, means you are studying here the composition of the matter. This is composition of matter you studied. And along with that, when you arrange the atoms, okay, the different atoms you arrange, and you will find that there is exact structure is formed here. Let me draw a structure here. So you can notice that the atoms now forming exact structure means it forming here cube. Different matters contain different kind of structural arrangement of atoms. But here you got one point that in this the atoms arranged perfectly. That you studied by knowing how the atoms are arranged in a structure. Therefore you study here structure of atoms, structure of matter. Okay. Next, once you got the composition and the structure, you try to react the atoms with the other reagents or other chemicals like acids, bases, and all. So by knowing or studying the reactivity of the matter with some other chemicals, we come to know that what are the different properties are there. The properties also include that what is melting point, what is boiling point, what is the state of the matter, whether it is solid, liquid, or gas. All these things we studied in the properties of the matter. Okay, so therefore we can say one point that chemistry we can define now. In the chemistry we mainly do the three things: the composition of the matter, structure of the matter, and properties of the matter we study. Therefore the chemistry is a branch of science, okay, which deals with the you can say that three components should be there. There's the first, there's composition, structure we have to take, and properties, right? These three things should be there in that, which deals with the composition of matter, right? And the structure of matter, and properties of matter. Okay, this is the definition for the, you can say that, chemistry. You have to remember that what is the chemistry. Chemistry is a branch of science which mainly deals with the composition, structure, and properties of the matter. Chemical classification of matter. Chemical classification. So in the chemical classification, we mainly focus about the chemical properties. Based upon the composition of the matter, the matter is divided into two parts. The one is here, we're going to list out, that is called as pure substances. And the second one is mixtures. Now we'll discuss only about the pure substances. Okay. The first one, that is A, the pure substances. The name itself explaining here that what are the pure substances. The pure means it should made by only one type of material or one type of substance. Okay, so it is a substance. It is a substance which cannot be separated by physical method. Okay, and one more thing, it is single substance. Let me write it, not substance, it is single substance. Single substance. Substance. And this is so much pure that we cannot differentiate the substance of each particles, or different particles we cannot identify here. We can say that all the particles or all the substance have same properties and same observations or same view is there. Therefore, it is a single substance and cannot be separated, and which cannot be cannot be separated by physical methods. And one thing that physical methods, we can list out them. Physical methods like let me draw only here, just list out all physical methods here. The physical methods maybe here we can take like you can say that hand picking. What is the meaning of hand picking? Hand picking means, so I think most of the people know that if while cooking a rice, you have to clean, you have to separate the rice particles from the other unwanted materials. That is by using a technique called as hand picking. You can use the filtration technique. Filtration. Okay. Even you can use here the distillation. Okay. And even sometimes you can use crystallization process. So in all these techniques, you are not changing the physical or chemical state of the matter. That remains same. Okay. Now the pure substances are again classified into two types. The one is called here as elements, and the second one is called here as compounds. These are the two major type of classification is there, that is elements and compounds. So first we'll discuss the elements. The first one, elements. So what are the elements? The elements are nothing but a pure substance only, right? But the thing is that they consist of only one type of particles. Okay, an element consists only one type of particle. One type of particle here. Okay, the particle may be atoms or molecules, and these particles may be atoms or molecules. Okay, now these particles we can classify. Don't get confused. Only they should be atoms, not like that. They should be, the particles means they should be here atoms, or they may be molecules, right? You should remember that. Don't get confused that particles means only some students write it is a atom, but it's not. They may be atoms or they may be molecules, but they should be only one type. There is no different types. Okay, now let me take some examples to understand this. Okay, so what we can have here, if I have a piece of metal here, okay, this is a piece of metal. Now this piece of metal contains only one type of, okay, here some error has happened, only one type of atoms may be present. Like, so in this, some atoms are present, like sodium metal. Let me write sodium metal. Only sodium metal atoms are there, or there may be a silver atoms, or there may be a copper atoms. Only one type of material should be there. It's the purest form of the substance or purest form of the metal. Okay, and one thing you know that if I take sodium metal and silver, they both have different in the nature. Means same atoms, if I take two sodium atoms, both have here same properties. Okay, but when I take a silver and sodium, these two have different properties. Therefore, we can say one statement that say different, okay, atoms of different element have different nature. Atoms of different elements have different nature. This is known thing, right? The silver and sodium are never be same, but two sodium atoms are there, then they are same, right? So now leading to the next explanation, some of the elements such as sodium, copper, they always contain a single atoms here. single atoms held together by metallic bonding, okay, and constitutes the entire crystal. Whereas there are some other substances are there, like elements are there. They two or more atoms get combined. Okay, let me take here atoms, atom plus atom. Okay, any number of atoms, minimum two atoms they combine, and result here molecules. Molecules. That is, two or more atoms get combined and form a molecules of the element. Element. For example, if I take hydrogen atom that is combining with another hydrogen atom and forming here hydrogen molecule, the molecule of element it is. Okay, if I take oxygen atom combining with another oxygen atom and forming here oxygen molecule of element it is. Okay, so only thing is that when oxygen and nitrogen and hydrogen, when they talk, they consist of molecules in which the atoms combine to give respective molecules of elements. Okay, so that's it. So any atoms, same type of atoms, they combine and form the molecule of that particular element. Okay, now come to the main point, that is second one, that is compounds. Compounds here. Compounds. Now when we talk about the compounds, first understand that what they are. Usually compounds are the classified part of the pure substances, therefore we can write with the pure substance. Compounds are pure substances. They are pure substances. Pure substances. Okay, this is one point you have to remember. And what they are containing? Containing two or more elements. Let me write here elements combined together in a fixed proportions by their weights. And one more thing we can add in that, and also you can separate them. Okay, by chemical reactions or chemical methods, you can separate the elements into the, or you can molecule or whatever the substance is there, you can separate them into elements. Okay, so therefore you can say that, and can be decomposed into, and also can be decomposed. I will give an example for this. Can be decomposed into elements by chemical methods or suitable chemical method. Generally you can write chemical methods. Okay, now let's understand some more things related to this. If I have the water molecule H2O, okay, if I take two water molecules here, whatever is the source, the one water molecule is taken from the lake, the other one is prepared in the lab, whatever is the source here. In this molecule, whatever the parts of hydrogen is there, or mass of the hydrogen is there, and mass of oxygen is there, that should be always constant. Therefore, weight ratio is equal to weight of hydrogen and divided by weight of oxygen. We know that weight of hydrogens, that is total number of hydrogen in a water molecule, there are two water molecules are there, two hydrogens are there. Therefore 2 into 2 hydrogens in a one water molecule, 2, the weight of hydrogen, it should be 1.008 is there, but for the calculation purpose I will take 1. Now weight of the oxygen is 16. Okay, and then we get it is 2 by 16 get cancelled, and from here 1:8 ratio. Okay, that is from the lake. In the laboratory also we can prepare the water. We can write the weight ratio for this. Weight ratio, that is exactly equal to weight of hydrogen divided by weight of oxygen, and that's equals to what you get here, 2 into 1 divided by 16. Same to same calculation, 1:8. Now we can predict that whatever is the source, lake or lab or rain or whatever it is, or the sea water, the hydrogen and oxygen combined in the same ratio of their weights. So therefore we can say that in water, in the water molecule, that is one part of hydrogen, one part of, let me take a little bit up, one part of hydrogen combined with 8 parts. Here is the 1:8. The one part of hydrogen combined with 8 parts of oxygen. Still you can use more sophisticated terms like 8 parts by weight. Also you can use the term. But let it be, this is sufficient to understand the concept. Okay. Now, moreover, the properties of the compounds are altogether different from the constituent elements. You know that. So when I take an example of water, H2O, it having certain properties, you know well about this, right? But when you take a hydrogen and oxygen, so these two elements have different properties. These are different properties. Okay. And when oxygen and hydrogen, they combine and form a water, the water do not have any of the property of hydrogen or oxygen, right? So the properties of the compounds are entirely different as that of their elements which get combined. Okay, properties, let me write this. Properties, this is important part, students. Properties of compounds are altogether different from the constituting elements. You know that hydrogen is highly flammable, oxygen help in a burning, but water, the stop burning, right? It vanish the burn or the flame, right? So this is the properties we can list out here. Now the compounds are again classified into two parts. Simple part is that the compounds, there are two type of compounds are there. The one is called as organic compounds. Let me write. The one is called organic compounds. Organic compounds. The second one is here called as inorganic compounds. So then you may get a question that what are the organic compounds? So organic compounds are the compounds which are extracted from the living things, right? Like plant and animals. Okay. The compounds present in plant and animals. Okay. Example we can provide here. Example is that carbohydrates. You know that carbohydrates, glucose and all, carbohydrates, fructose, sucrose, you will get that all. And proteins, oil, fat, all these are called as organic molecules or organic compounds. Inorganic means they are obtained from non-living things, obtained from non-living things. So we can list out some examples here, like sodium chloride, common salt, sodium chloride, NaCl, marble, gypsum, washing soda we can take, gypsum you can take. So these are the few examples for the inorganic compounds. Hope you understood this, right? In the next video, I'm going to explain that what are the mixtures, and also I will explain you that what is the difference between the compounds and mixtures. Thank you for watching it, students. Now we're going to study the classification of matter. So first understand that what is matter. The matter may be anything. The matter should have two important components. The matter should have the mass, and the same matter should occupy some space in the some space it should occupy, means it should occupy certain volume. It should have volume, and that itself is called as a matter. The matter should contain a mass and volume. Okay, we can give a numerous examples for this. For example, if you're holding a pen, the pen is a matter because it having the mass and volume. Air is a good example. Water, book. Okay, many things you can write. Okay, now the matter is mainly classified into two parts. Two parts means two way of classification is there. The one classification is known as physical classification or physical properties. Physical properties. Physical properties, and second one is known as chemical properties. Chemical properties. Okay, fine. Let's understand that what is a physical property. First, we'll discuss this. Okay. Let me draw a box for this. Okay, now in the physical properties, we study generally the state of the matter. States we are discussing here. States of matter at room temperature. At room temperature. Room temperature and pressure. And by that we come to know that there are three major states are there. The one is the solids. Second one is liquids. And third one is gases. Okay, let's understand that what are the solids. The first one, A, solids. When I talk about the solids, the one thing come in the mind that solids are compactly arranged. If I arrange the atoms of the solids, this is the one atom of the solid, and this is exactly cling or touch the another atom, and this continues, and very compact type of arrangement is there in the solids. Let me draw one more. Here is one atom, and here is one atom. I'm going to write. You can see that the atoms are very compactly arranged. Okay, this arrangement is very compact due to the only one reason, that the force of attraction between the particles is very strong. So therefore, the first point we can write here, the force of attraction is high. And because of this reason, the distance, you can see that the distance between the two particles is very small. So interparticle distance is very small. Okay, and because of these two reasons, we can say that the particles are compactly arranged. Particles are compactly arranged. You may get a question that why you can say that the solids contains the very compactly arranged arrangements. You can say that the force of attraction is very high, and because of that, interparticle distance is very small. Therefore, the particles are compactly arranged. Now, the question comes that whether the particles are move or not. Yeah, obviously particles can move. The movement is very restricted here. Let me select this atom, and this atom is moving. This atom is moving only from its mean position, but is not moving outside randomly in all possible directions. But it is restricted. It having a restricted movement. The particles are moving or vibrating. You can say that they are vibrating from their mean positions. So therefore, I can write one point that here. Let me list out this. The the position of the particle is fixed. Positions. I will write positions of particle is fixed. It is fixed. No freedom of movement. But it's not the final case. The particles can move from their mean position, right? So therefore, we can list here one point that the particles can vibrate from their mean position. Right. So all these things give us a very basic information that the solids Solids have fixed geometry. Fixed geometry, you can say that you can take it as shape, fixed shape. And solids have fixed volume. Because the particles are not moving means the volume is also constant here. And this is all about the solids. Let's understand the liquids. B, we're talking about liquids now. Liquids. Let me take an example. Take a container. Okay, let me draw a container here. Now, here is a container, and in that container, I'm going to fill some water. You can see that the water molecules are very close, but they are not touch each other, but they are very close. Okay, now you can notice that the force of attraction is exist, but it is very less. Okay, very low force of attraction. Low force of attraction. Okay, and because of that reason, there is interparticle distance is there, but that distance is minimum in the liquids. That is minimum. The interparticle distance. Let me list out that interparticle distance is minimum. Hope you understood that. So one thing, you don't compare the distance with the solids and liquids, because in the solids interparticle distance is completely zero, or it is very very small, but interparticle distance in the liquids, it is minimum. You remember this sentence is very important. And as it having a low force of attraction and there is a interparticle distance is minimum, the particles are move randomly. Let me select one of the particle here, and this particle can move in all possible directions. It can move here, it can move here, it can come here. The particle can move in any direction in all possible ways. Okay, now what you can say that the particles has freedom of movement. Okay, freedom of movement. But the thing is that the freedom of movement is in all possible directions. Okay, so therefore I'm using here freedom of movement. It is all possible directions they are moving. And because of this reason, all these points tell us that the liquids can flow. Therefore they are called as fluids. Okay, the fluid term comes from the flow term. The liquids can flow. They are fluids. Okay, liquids has definite volume. Definite volume means the distance between the particles is very small. The volume is constant for this. But the liquids don't have don't have definite shape, because already you know that if you take a bottle and pour in the water in that, the water takes the shape of bottle. The same water, if you put in another bottle, if the different shape, the liquid or water gains the shape of the bottle, right? So therefore we can say that the liquids don't have any definite shapes, but they have a definite volume. If you take 1 liter of water, it remains as that up only, but by changing the different sizes of the container, the shape of the you can say that liquid also get changed. Okay, come to the last part, that's gases. The third one we're going to discuss, the gases. So let me take an example here. Let me draw a container, a simple container I'm going to draw here. So in that the gas molecules are present like this. These are the gas molecules. The interparticle distance of between the gas molecules is very high because the force of attraction is very less. Force of attraction is very very low. It is very low. Okay, and because of that reason, the distance between the two particles is very high. That is interparticle distance. Particle distance distance is very high, is maximum, I'm going to write maximum. And because of this reason, this particle or gas particle has a plenty of freedom of movement there. Okay, so therefore we can write here the particles move in all possible directions, in all possible directions. And during this process they will collide with the wall of container, collide with wall of container, and because of that reason they produce a force, and that leads to the production of pressure. Container hence exert pressure. Okay, this is a new term came here, pressure. Now, as the particles are moving in all possible directions, and because of that reason we can say one more property is arised, that is gas molecules don't have a definite volume or definite shape. So the gases do not have definite volume and shape, or geometry, you can say the shape, because the shape of the gas is nothing but a shape of the container, right? Because all the gases are moving in all possible directions, therefore they attain the shape of the container. This is all about the classification of matter according to the physical properties. Okay, in the next video I'm going to explain you that how the matter is classified according to chemical properties.